let's start the session. Yeah, hello, hi everyone, good evening. So, welcome to ADDA247. Today, our class is characteristics of DC motor. Today, our class is characteristics of DC motor. సో లైవ్లో ఉన్న వాళ్ళు ఎవరైనా మీ ఫ్రెండ్స్కి షేర్ చేయండి. సో మనకి నంబర్ ఆఫ్ క్యాండిడేట్స్ ఇంక్రీజ్ అవుతారు. So Lokesh, are you preparing for SSC JEE exam? So am I audible? So those who are in the live session, please comment whether voice is audible or not and the screen is visible or not. So everything you should give a comment. Okay. So anyhow, we are going to start the session. So today our class is characteristics of DC motor. So how we can draw the characteristics of DC motor? What are the characteristics we can classify? So based on the torque and speed and armature current. So that we can going to discuss today's session. Okay. So if you are not downloading this ADDA247 app, you can download ADDA247 app in your mobile. So then as usually you will get the latest notifications and current affairs, job alerts and daily quizzes. So everything is available in the app. Okay, so you can download and you can subscribe. If you can subscribe channel, so then you will get the latest notifications. So every day we are going to conducting live classes for different competitive examinations. Okay, so now we are going to enter into the characteristics of DC motors. So generally DC motors are classified into various types depends on the field winding connection. Okay, so based on the field winding connection, okay, so this classified into separately excited, so second one is self excited. Okay, so mainly these are the two classifications. Again, self is classified into three types: series motor and shunt motors. Another one is compound motors. So these are the different types of motors. We are going to draw the characteristics for these motors. Okay, so based on the field winding connection, these are the classifications: separately excited and self excited. So this self excited is divided into three types: series and shunt and compound. Okay, so now we are going to discuss the characteristics of series and shunt motor characteristics today. Okay, so now first we go with the shunt motor. Okay. So shunt motor means the field winding is connected in parallel to the armature. We can call it as a shunt motor. You can see the each and every parameters I represented here. This is the line current I, and this is the armature current direction IA, and this is the shunt field current direction ISH. Okay. So the shunt field resistance is RSH and armature resistance is, this is the armature, and this armature resistance is RA. The EMF induced in the armature, that is back EMF, that is EB. Okay. So we know all the parameters. Then we are going to draw a characteristics for DC shunt motor. Okay. So now you can see for a shunt motor, the field winding, that is the field winding, the flux produced in this one is pi SH. The flux produced in the shunt field winding is pi or pi SH. So that is directly proportional to the current passing through the field winding. So then current increases, flux increases. You can see the relation. That must and should remember. The flux produced in the field winding of shunt motor. So this is the flux shunt. So or else you can represent pi only. Okay. So no need to bother about this one. The representation. The flux produced by this one is directly proportional to current passing through the same coil. That is ISH here, I represented here, ISH. So then ISH increases, ISH is increases, the more current is passing through the field winding, then more flux is produces. Okay. So then current is more, flux is more. Current is less, flux is less. Suppose current is maintained constant, the flux should be also constant. Okay, so that you can remember. So but the torque equation, you can see this is the torque equation. So the torque produced by the motor is directly proportional to P pi Z, ZIA into 2 pi A. So there is a derivation. So but I am taking here directly torque equation of DC motor. So as per this one here, these are the parameters are constant, flux, poles and total number of conductors and the parallel paths, all these are constant. So then we can assume this torque directly proportional to the flux into armature current. Okay, so we are assuming this is the constant. So the constant, whatever the parameters we are going to assume constant, that we are going to keep it Ka. So torque, finally torque is directly proportional to flux into armature current. You can remember, flux into armature current. Okay, so here the flux is directly proportional to current passing through the winding. Okay, so now IS is directly proportional to pi SH, or pi is directly proportional to ISH, whatever it we can assume. So that will be continue with the ending. So finally here we are taking the torque is directly proportional to the flux and armature current. But for a DC shunt motor, the flux is directly proportional to ISH. Okay. If ISH is constant, suppose for a shunt motor, the current is the constant, then flux remains constant. Okay. So flux is constant means, then what is the torque equation? Torque is directly proportional to only Ia, because the flux is constant. So constant means we are going to take it's a 1. So then torque is directly proportional to Ia. So then what will happen? Then current is increases, and torque is also increases. And current increases, torque. There is a linear relationship between the torque and armature current. So now you will get that straight line through the origin. So this is the torque is directly proportional to Ia. So this we are taking this armature torque TA, and this is the armature current Ia. Okay, simple way we can draw the characteristics of a DC motor if you know the equations. So that is why you must and should recollect the equations related to the torque and back EMF, flux, whatever the equations is required to draw the characteristics. That equations you should keep in mind. So based on that only we are going to draw the characteristics. Okay. Yes. Still, those who are in the online, yes, you can send this link to your friends so that they may also join with us. Okay. So this is the torque and armature current characteristics of a DC shunt motor. Okay. So for this reference, you need to remember this equation, all these equations. So torque equation, back EMF equation, that is the back EMF equation, EB is equal to pi ZNP by 60A. What is here N? N is the speed of armature and pi is the flux, total number of conductor Z, P is the number of poles, and A is the parallel paths. Okay. So from this equation you can see here, if you want to find the speed, armature current and speed torque characteristics, so you need to know the speed. You should be keep here speed. Then what is the equation you will get? EB into 60 into number of parallel paths A. So okay, so divided by, what are the terms you will get? Flux terms you will get, and Z terms you will get, and P terms you will get. So from this back EMF equation, if you want to know the speed of the armature, then N, speed is N is equal to EB into 60 into A by flux pi into Z into P. So all these terms is constant already. So this will be constant. You can assume 60A by ZP. So it will be constant. So either you will take either KAR something like that. So then finally what equation you will get? Speed is directly proportional to EB. Speed is directly proportional to EB. So and inversely proportional to flux. So this is the fine equation of the speed you can remember. Okay. So the flux will increases, speed will decrease. The flux decreases, speed increases. Okay. So but for a DC motor, what is the voltage equation? V is equal to EB plus IARA. EB plus IA into RA. So it is general DC motor equation. Okay. So from EB, from here EB is equal to V minus IARA. So you can substitute here. So here you will get speed is directly proportional to EB. EB is equal to V minus IARA. So then N is directly proportional to V minus IARA. Okay. So armature current and here flux. So you will get this equation. Okay. So now, so mainly we are going to draw the three characteristics: torque, armature current, speed torque characteristics, and speed armature characteristics, armature current characteristics. Already we know this is the torque and armature current, just now only we drawn. So then torque is directly proportional to armature current. So torque is directly proportional to armature current. Then torque is increases, armature current is increases. So when armature current will be 0, torque will be 0. Armature current will be maximum, then torque will be maximum. So here suppose it is a current is maximum, here torque is also maximum. Okay. So this is the relation between the torque and armature current. So next, suppose if you want to draw the characteristics of armature current and speed, what you will get here? So then current increases, speed will decreases. So means, so it is a, so from this one you can see here. So this is a speed, then current is here, minus is there, then current is increases, then the speed will be decreases. Okay, so that way we can draw the characteristics here. So then speed is directly proportional to V minus IARA. Okay, V minus IARA. So then current will increases, armature current is increases, then what will happen? The speed will be decreases. Okay, so both are like a inversely proportional, then current increases, the speed will decreases. So next, coming to the torque speed characteristics of a torque and speed. So the relation here, torque is increases, the speed will decreases. So how it is, you can see here. So this is the torque equation. Okay, torque is directly proportional to pi into flux into Ia. Okay, so but we are going to draw a torque relation with the speed. Okay, so here what will happen? Then current is increases, speed will decreases. Okay, so then current will increases, speed will decreases. When speed will decreases, then what will happen? The torque will decreases. So because here minus, current is minus, it is decreasing, then speed will increasing. Okay, so this will increase and this will be decreases, like that. So then current will increases, that speed will be decreases. So similarly, the speed is decreasing, then torque will increasing. Okay, so means the speed is, what it is, inversely proportional to the torque. So this is a torque. When torque is increases, the speed will be decreases. Okay, so these are the characteristics of DC shunt motor. So for these characteristics drawn, we must and should know these equations. So the relationship between torque and armature current, the relation between torque and speed, and the relation between the speed and back EMF, speed and armature current. So everything we want to know, then only we can able to draw the characteristics of a DC motor. Whatever the characteristics if you want to draw, so that almost depends on only the number of equations you know. If you know the equations, then we can easy to draw the characteristics. If you don't know the equation, so we are not unable to draw the exact characteristics. So that is why you must and should focus on the equations related to the machine. Whatever the machine characteristics if you want to draw, so that machine equation you must and should keep in mind. Then as per that only we can, parameter value we can assume whether the equations both are either proportional or inversely proportional, we can identify, and then we can draw the, so whether it is proportional, so there is a linear relationship between the both values. If it is inversely proportional, so then it is a increase and decreasing mode. So in that way we will get the characteristics of a machine. Okay, so next coming into the next applications, we can see here general applications of a DC shunt motor. Okay, so it is a current is constant, the flux is constant. That is why DC motor, shunt motor is a constant speed and constant flux motor. Okay, so you can keep in mind in exam point of view. So this is very important bit. Okay, so DC motor is a constant speed motor, DC motor is a constant flux motor. Okay, so flux is constant, current is constant. So then, so where we are using this one? So general, I have given some example: lathe machines and drilling machines, grinders, blowers, compressors. So these are the some applications of DC shunt motor. Now similarly, DC series motor. DC series motor. How we can draw the DC series motor characteristics? So similarly, what are the equations we want to know? Okay. So how we can draw the torque speed characteristics and speed armature current characteristics. Okay. So then how we can draw the torque versus armature current characteristics. Okay, so everything, all these characteristics of the series motor or shunt motor or whatever the motor, so based on these equations, mathematical expressions. Okay, so that is derived from the machines. So if you know the equation exactly, then we can easy to draw the characteristics. Now you can see. So how we can say that this motor is series motor? How we can say? So I already told the types classification is based on the field winding connection only. Field winding connection. So based on this field winding connection only, the motors are classified. So here the field winding, this is the field winding. The field winding is connected, so in series with the armature. This is the armature. So whenever these both are connected in series, so then we can say the motor is DC series motor. Okay. So now we are providing supply from these terminals, positive and negative terminals. So now you can see in this below diagram. So this is the positive polarity and the negative polarity. Then supply is passing from like this. Okay. So here there is a armature. That is the armature current. This is IA. Okay. So this is IA. The current is passing through the armature is IA. So this I represented here. So now this is the current is delivering from the source, that is the line current. So this is IL. Okay. So now same current is passing through the series field winding, so that I can say this is the ISE. ISE is the current passing through the series field resistance, RSE. Okay. So now what are the currents are existed here? How many currents are there here? 3 currents are there. One is IL current, line current. So another one is ISE current, series field winding current. So another one is armature current. So these are the 3 currents are there. So but here as per the classification, the field winding is connected in series with means, so current is always same in series circuit. Current is always same in series circuit means, so this all current must be same or equal. Okay. So the currents delivering from the source must be equal to the Raju. Okay. So are you preparing for any competitive exam? So anyhow here the winding is connected in series with the armature, we can say DC series. So for a series motor, so the current delivering from the source IL, so that must be equal to the current passing through the series field winding, that is equal to the armature current. Okay, so the current will be same. So but you have to know the torque is directly proportional to flux into armature current, you can keep in mind. Okay, so if you want to draw the characteristics, you must and should know the relationship between all the terms. Okay, so for this series field windings here, so then ISC is equal to, so ISC is directly proportional to flux. Then series field winding current is increases, the flux in the series field current is winding also increases. Both are directly proportional each other. So what we can see, then what will happen in the characteristics drawn cases. So because the ISC is equal to IA is equal to IL, so instead of this ISC, so it is possible to substitute IA also. Okay, so because the current is always same in a series circuit, now you can see, so we can draw the characteristics of a DC series motor. Same characteristics you will get: torque armature current, speed armature, and speed torque characteristics. Okay, so how we can draw, so how we'll get the equations, characteristics you can see here. So I am giving some relations here, so you can keep in mind. So torque is directly proportional to pi Ia, but Ia is equal to If is equal to, If means field, so I represented here ISC is equal to Ia, I means IL, line current. So all are equal. So but torque is directly proportional to flux into Ia. So from this one you can see, so torque is directly proportional to flux into Ia, but flux is directly proportional to Ia. So here I represented here, flux is directly proportional to Ia from this winding. So you can substitute here flux, instead of flux you can substitute Ia. So then what is the final equation you will get? Torque is directly proportional to square of armature current. Torque is directly proportional to square of armature current. So then what will happen? So you will get, so waveform, it is not straight line, so you will get like this. So if it is directly proportional, you will get straight line. Okay, so from this one you can see, if you want to draw the speed relation, then speed is directly proportional to EB by pi A. Okay, EB by pi. So then speed is directly proportional to EB and inversely proportional to flux. But flux is directly proportional to armature current. So instead of flux, you can substitute armature current. So then what you will get here? So speed is inversely proportional to armature current. Then armature current increases, speed will decreases. Then armature current increases, speed decreases, means torque is also decreases. So now you can see here. So this is the relation between the torque and armature current. So then armature current increases, so then torque is also, it is a square. So torque is directly proportional to armature current square. So that is why, so we'll get like a hyperbola line. So it is not straight line. So next, so speed and armature current. Speed and armature current. When armature current increases, then speed will decreases. So at the minimum value of the armature current, the speed will be maximum. The speed will be maximum at minimum value of armature current. So now gradually the current is increases to maximum. So here the current is maximum, then the speed will be minimum. The speed will be minimum. So you will get the relation from here. So speed is inversely proportional to armature current. Means, okay. So next here, torque speed characteristics. Torque and speed characteristics. So you will get indirect relation between the torque and speed characteristic. When the speed is decreases and torque will increases. So at a minimum torque here, so this is the minimum value of the torque. So the speed will be maximum. So that's why DC series motor is a high starting torque. So at low speed, when speed is 0, so here suppose speed is minimum, so then the torque will be maximum here. Torque will be maximum. Okay. So these are the relation between the torque speed and armature current speed and armature current and torque characteristics of a DC series motor. Okay. So you can keep in mind, you can remember. Okay. So the equations, as per the equation only we can get the characteristics of DC shunt motor or series motor and whatever the motor we are going to discuss. So that is based on only mathematical expressions. Okay. So those who are in the live session, you can send this link to your friends. So number of students will be added. Okay. So am I audible? Those who are in the live session, you can give a comment. Am I audible or not? సో ఎవరైతే లైవ్లో ఉన్నారో లైవ్ చూస్తున్నారో కామెంట్ చేయండి. సో నా వాయిస్ వినబడుతుందా లేదా అనేది. ఓకే. సో ఇఫ్ ఐఎమ్ ఆడిబుల్ దెన్ ఐ విల్ కంటిన్యూ. Okay. So these are the characteristics of DC series motor. So shunt motor, series motor characteristics. So some applications of DC series motor. What are the applications? So wherever the starting torque is high is required and quick acceleration is required. Okay. So at that area we are going to use DC series motor. So example of traction, rolling mills, conveyor belts, cranes, hoists, lifts. So in these machines, in these industries we are going to use, in these machines or industries, this kind of industry. So we can use DC series motors. Okay. So next classification is DC compound motor. Okay. So as per the field winding connection, so we can classified. So for a compound motor is the combination of series and shunt motors. So it is the combination of series and shunt motors. Okay. So how we can draw the characteristics of this is series and this is the armature. Okay, and this is the armature and this is series winding and shunt winding. Okay, so based on this connection we can classify long shunt, short shunt and cumulative and differential compound motors. Okay, so how we can elaborate you can see here. Okay, so we're talking about here a short shunt DC compound motor. Short shunt means the shunt field winding is connected only in parallel to the armature, we can say short shunt. If it is a long shunt, so the field winding is connected entire parallel to the, this is not their connection, and entire from long distance. Long distance means, so armature along with the series field winding. So we can say long shunt compound motor. Okay. So short shunt means shunt field winding only across the armature. Long means the shunt field winding is connected entire DC series motor. Okay. So now you can say here cumulative and differential compound motors are there. Cumulative means we are adding each other. So this is the positive polarity and negative polarity, and this is positive and negative. So whenever this negative is connected to the positive, so then we are going to add the flux of both series and shunt. This is the shunt and this is the series. So we are adding each other. So then the resultant flux will be more. Resultant flux will be more. Okay. So this kind of motor we can call it as a cumulative compound motors. Okay. So if it is a differential, so we can say, so it is a minus and it is a plus here. Plus is connected to plus or minus is connected to minus. So then both are opposing each other. Both are opposing each other means, so the resultant flux will be decreases, means pi SE minus pi SH. Okay. So the total will be less. So means it will be decreases. So this kind of connection is represented, then we can say it is a differential compound motor. Okay. So this is, you can see. So our aim is to draw the characteristics of a DC compound motor. Okay. So now you can see, so it is the combination of series and shunt motors. Okay. So you will take the relation. So you can observe most of the exams in competitive exams, so they are asking, they are giving this kind of graph, means so they will give speed and whatever the characteristics they want to give, they will give you as per like this. So they included all the characteristics in the one graph, and they will give you A, B, C, D like that, A and B and C like this. So this is ABC, this is D, and this is E, and this is F. Okay. In examination point of view, they will give you like this. So which one of the following is related to the cumulative compound? Which one of the following is related to the shunt motor? Which one of the following is differential compound? So they will ask you like that, armature for a armature current and speed characteristics, for a armature current and torque characteristics, and torque and speed characteristics. So they will give you like this as per the equations. Okay. So when flux is adding each other, and the flux is subtracting each other, and adding each other is cumulative, subtracting each other is differential. Okay. So now you can see this is the differential compound motor and shunt motor and cumulative compound motor. Okay. So this is the differential compound motor, shunt motor and cumulative compound motor. Okay. So this is the differential compound and cumulative compound, and this is the normal range. Okay. So it's the normal speed. The speed is above the normal is differential, below the normal is cumulative compound. Okay. So here also speed characteristics, this is the normal range. So above is differential and below So very close to the constant value. This is the constant value. So very close to the constant is shunt. Okay, because a shunt motor is a constant flux and constant speed motor. So it is very close to the normal value. So below is cumulative. So you can easy to identify the relationship between speed characteristics and uh, armature current and speed, armature current and torque characteristics. Okay. So these are the characteristics of DC motor. సో ఈ క్యారెక్టరిస్టిక్స్లకి వెళ్ళి కంపల్సరీగా క్వశ్చన్స్ వచ్చే అవకాశం అయితే ఉంది. ఓకే, సో మీరు గ్రాఫ్లు చూసుకున్నా కానీ మీకు ఈజీగా 1 మార్క్ 2 మార్కులు అయితే క్యాచ్ చేసే అవకాశం ఉంటుంది. ఎందుకనంటే సో ఈ ఈక్వేషన్స్ అండ్ గ్రాఫ్ చూసుకుంటే మీకు మినిమం మార్కులు అయితే 1, 2 మాత్రం అయితే వచ్చే అవకాశం అయితే ఉంటుంది. ఎందుకంటే ఒకవేళ క్యారెక్టరిస్టిక్స్ మీద అడిగి గ్రాఫ్ల మీద అడిగినా, ఒకవేళ ఆ రిలేషన్స్ మనకి ఆ ఈక్వేషన్స్ తెలిసినా కానీ మనం ఆన్సర్ చేసే అవకాశం అయితే దెర్ ఈజ్ ఏ పాసిబిలిటీ టు ఆన్సర్ ద క్వశ్చన్ ఇఫ్ యూ నో ద ఎగ్జాక్ట్ ఈక్వేషన్స్ అండ్ ఇఫ్ యూ ఐడెంటిఫై ద క్యారెక్టరిస్టిక్స్. ఓకే, మనం వీటి అప్లికేషన్స్ అయితే ఒకసారి చూద్దాం. ఎక్కడెక్కడ వాడతాం, క్యుములేటివ్ కాంపౌండ్ మోటార్ ఎక్కడ వాడతాం. ఓకే, సో హై స్టార్టింగ్ టార్క్ ఎక్కడైతే ఉంటుంది లైక్ DC సిరీస్ మోటార్. సో ఎలివేటర్స్, రోలింగ్ మిల్స్, పంచెస్ అండ్ ప్లేనర్స్. సో ఇక్కడైతే మనం యూజ్ చేస్తాం అనేది ఈ అప్లికేషన్స్ అనేది ఎక్కడైతే యూజ్ చేస్తాం అనేది ఆ డివైస్ ఎక్కడ ఏ ఏరియాలలో వాడతాం. సో దట్ ఈజ్ అప్లికేషన్స్. ఓకే, సో మనం చూసినట్లయితే ఇక్కడ హై స్టార్టింగ్ టార్క్ అయితే ఉంటుంది క్యుములేటివ్ కాంపౌండ్కి. సో దెన్ ఆపరేట్ ఈవెన్ ఎట్ నో లోడ్స్ ఆల్సో దే రన్ ఎట్ మోడరేట్లీ హై స్పీడ్. నో లోడ్లో కూడా మోడరేట్ హై స్పీడ్తో అనేది మోటార్ రన్ అవుతుంది. సో మనం అది షుడ్ కీప్ ఇన్ మైండ్. సో డిఫరెన్షియల్ కాంపౌండ్ మోటార్ చూస్తే యూ కెన్ సీ సో ఇంక్రీజ్ విత్ ద ఇంక్రీజ్ ఆఫ్ ద లోడ్ విచ్ లీడ్స్ టు అన్స్టేబుల్ ఆపరేషన్. స్పీడ్ అనేది లోడ్ ఇంక్రీజ్ చేస్తే ఇంక్రీజ్ అనేది అవుతుంది. సో ప్రాక్టికల్గా అయితే ఈ మోటార్ మనం అయితే వాడట్లేదు. ఓకే, సో డిఫరెన్షియల్ కాంపౌండ్ అనేది ఎందుకంటే రిజల్టెంట్ ఫ్లక్స్ విల్ బి రెడ్యూస్ అవుతుంది కాబట్టి సో అప్లికేషన్స్ అనేది పెద్దగా ఏం లేవు. సో మోస్ట్లీ ద డివైస్ వాట్ ఎవర్ ద డివైస్ ఇస్ గివ్స్ బెటర్ పర్ఫార్మెన్స్. సో మోస్ట్లీ we focus on that kind of devices only. Okay, so these are the characteristics of DC motor. సో ఈ DC motor characteristics అనేది మీరు multiple times you can listen the video. Definitely you will get 1 or 2 marks from this today class. Okay, లైవ్ క్లాసెస్ అనేది సేమ్ టైంకు ఇప్పటి నుంచి 10:15కి స్టార్ట్ అవుతుంది. లైవ్ క్లాసెస్ టైం అనేది చేంజ్ అయింది. సో మీరు 10:15 నుంచి మాత్రం అయితే క్లాస్ స్టార్ట్ అవుతుంది కాబట్టి మీరు సో ముందుగానే అలర్ట్గా ఉండండి. ఓకే, సో ఈ క్యారెక్టరిస్టిక్స్ అయితే ఈ ఈక్వేషన్స్ అయితే చాలా ఇంపార్టెంట్. ఓకే, సో మీరు క్లాస్ మీద కామెంట్స్ ఇవ్వచ్చు. ఓకే, సో ఇఫ్ యూ నీడ్ ఎనీ మోర్ దాన్ దిస్ వన్ సో డెఫినెట్లీ వీ విల్ ఫోకస్. ఓకే, సో యాజ్ పర్ యువర్ రిక్వెస్ట్ అండ్ కామెంట్స్ we will change our whatever the explanation process will be changed. So we are focusing on just like a examination process. That is why we are directly explaining. Okay, we are taking the direct equations and we are explaining so how we are getting this equation characteristics. So you need any extra, so what you are expecting, so you may comment in the live chat. So we can change, we can as per your request, we will add the additional parameters, additional features. Okay. So next tomorrow, so we are going to discuss characteristics of DC, generator characteristics మనం డిస్కస్ చేస్తాం. సో మీరు అప్పుడు మోటార్ క్యారెక్టరిస్టిక్స్, జనరేటర్ క్యారెక్టరిస్టిక్స్ కంపేర్ చేసుకుంటే సో మీకే అర్థమవుతుంది. సో వాట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ మోటార్ క్యారెక్టరిస్టిక్స్ అండ్ జనరేటర్ సో ఇన్ మోటార్లో ఏమేమి క్యారెక్టరిస్టిక్స్ ఉన్నాయి, జనరేటర్లో ఏమేమి క్యారెక్టరిస్టిక్స్ ఉన్నాయి అనేది సో యూ కెన్ గెట్ అవేర్నెస్. ఓకే. So thank you all. So now I am going to end the session. Good night. Bye bye.